picture an environment that is constantly hovering right at the boiling point of water, 100 degrees Celsius. Now, that's an extreme, punishing temperature all on its own, right? But what if I told you that the heat is actually the least of your worries? Because in this specific scenario, that 100 degrees is the temperature of boiling hydrochloric acid, HCl. This is an incredibly highly corrosive medium. I mean, if you were to just drop standard industrial measuring equipment into this stuff, it would fail almost instantly. The metals would literally corrode away, the electronics would short out, and your entire process monitoring would just go blind in what is, frankly, a highly dangerous situation. So welcome to The Explainer. Today, we are looking at the exact technology that is engineered to survive this nightmare scenario. We are going to focus on a highly specialized piece of equipment, specifically a PT100 RTD assembly made by Mark, and we're going to uncover exactly how it's designed to operate in such a hostile world. Okay, let's dive into this. We're going to cover surviving severe corrosive environments, the anatomy of the RTD assembly, the proprietary Mark transmitter, and finally, a real-world commercial quote.
First up, surviving severe corrosive environments.
So chemical and petrochemical plants rely on incredibly volatile liquids, and to monitor them safely, they use something called an RTD, or a resistance temperature detector. To just demystify the jargon for a second, an RTD is a highly accurate sensor. It doesn't use expanding liquid like your old-school mercury thermometer. Instead, it measures temperature by correlating the electrical resistance of its internal element with the temperature outside. Basically, as it gets hotter, its resistance changes in a highly predictable way. And here is exactly what that device looks like. This specific Mark design is built for continuous operation, meaning it's constantly measuring temperature while submerged in highly corrosive liquids like HCl acid, all the way up to 100 degrees Celsius. Every single component you are looking at has been deliberately chosen to prevent that boiling acid from breaching the system.
Part 2. Anatomy of the RTD assembly.
Now, the absolute most critical piece of this physical armor is the thermowell. You can think of a thermowell as a heavy-duty protective sleeve. It's a cylindrical fitting that completely shields the sensitive inner temperature sensors from the pressure, the flow, and, most importantly here, the extreme corrosive chemicals of the industrial process. Without the thermowell, the RTD wouldn't stand a chance. Let's break down the structure from top to bottom. At the very top, you have the SS316 stainless steel terminal head, which includes a standard half-inch NPT cable entry. Moving down the device, we have 600 millimeters of sheathing, which is also made of that tough SS316. But the real magic happens at the bottom, where this actually mounts to the tank, or pipe. You have a 150 millimeter outer diameter PTFE flange that integrates seamlessly with that protective thermowell we just talked about. The specific materials driving this design are actually fascinating. The thermowell itself is machined from drilled bar stock PTFE, which is legendary for its chemical resistance. Inside all of that, the construction is mineral insulated. That provides incredibly high accuracy and stability over time. The electrical setup is a 3-wire duplex configuration, giving you super precise readings, and the whole thing operates at a strict Class A accuracy standard. But here is the major safety feature that sets this specific model apart from the pack. In a standard assembly, you often have a physical joint right where the thermowell meets the flange. And in engineering, a joint is always a potential weak point. But the Mark design? It features absolutely no joint between the thermowell and the 12 millimeter thick PTFE flange. It's carved from a single piece of PTFE material. This ensures literally zero leakage, which is giving you maximum safety when you're dealing with something as unforgiving as boiling acid. Part 3. The proprietary Mark transmitter. Okay, so protecting the sensor is obviously a huge deal, but that's really only half the job. The other half is communicating the data clearly. The assembly features the proprietary Mark transmitter. As you can see, it has this really beautiful, highly visible digital interface, currently displaying 150.0 degrees Celsius, that ensures operators on the floor can get clear, immediate readings without having to guess. And the internal electronics totally match the rugged exterior. It utilizes an industry-standard 4 to 20 milliamp linearized output, it handles a wide supply range, and its operational temperature reading spans from 0 to 150 degrees Celsius. It also features reverse polarity protection, because you definitely want to prevent electrical mishaps during installation, and perhaps most conveniently for the engineers, it has a built-in software calibration facility that makes high-accuracy configuration in the field just incredibly easy. Part 4. The real-world commercial quote. Now, engineering doesn't happen in a vacuum, right? It's a business. So let's see how all this builds a complete commercial picture. We can look at the highly technical data sheet we've been breaking down right alongside the actual official quotation generated for this exact item. This connects the complex engineering specs directly to commercial reality. We can see this was prepared by Anirudh from Mark and sent straight to Ami Kumar at Tata Steel Limited, specifically for their wires division at the Indernagar Works over in Jamshedpur. Now, I have to point out a highly relatable administrative quirk here on the quotation document. Right below the address, there's this beautifully detailed table with 24 precise line items outlining our complex PT100 RTD temperature assembly in all its glory. But if you look really closely at the subject line of the letter itself, it reads, Offer for Crane Voice Hooter. It is such a great reminder that even when you are dealing with zero leakage boiling acid containment, simple copy and paste errors on office paperwork still happen to the best of us. But jokes aside, the crucial point here is understanding the business terms for acquiring this level of industrial safety. For a single unit of this highly specialized, custom-engineered RTD assembly, the quoted rate is 11,500 Indian rupees. It carries an 18% IGST, requires a 7 to 8 week delivery window, which makes total sense when you remember its custom-drilled bar stock PTFE, and requires a 20% advance payment to get things moving. Honestly, this whole process perfectly summarizes the entire narrative arc of industrial engineering. Step 1 is identifying a severe threat, like boiling HCl acid in your manufacturing process. Step 2 is designing the physical solution, like that brilliant no-joint, zero-leakage PTFE barrier. Step 3 is integrating the smart technology, the transmitter, to give you accurate data. And finally, step 4 is the commercial deployment, where quotes are signed, hands are shaken, and the gear actually gets installed in major plants like Tata Steel to keep workers and processes safe. And that brings us to the end of our explainer. We have gone from extreme chemical hostility through precision engineering all the way to the final commercial invoice. It really makes you appreciate the completely unseen engineering that keeps global factories running safely every single day. So I'll leave you with this thought. How is your industry securing its most corrosive, dangerous processes? Thank you so much for joining me, and keep exploring the amazing engineering all around us.